Hello grade 12s, hello everyone, welcome to my channel. For those who have been here before and to those who are watching for the first time, I also welcome you. And please guys, do make sure you subscribe for next videos. Guys, we all know we are heading on to preliminary exams, and we are a few days away from writing, a few weeks from writing maths paper 1 and also paper 2. So for today's lesson, our focus is on counting probability. So this is this will be the last question on your prelim exam. So it's on probability, the last question on your examination paper 1. It's counting probability. It's a very small section. It's never worth more than 15 marks. It's always less than that. Counting probability. And then the problem now is that it gets complicated at times because there's a lot of formulas, and sometimes we don't know which formula to use when, and also there's stories, there's case studies, and interpretation of that can be a bit tricky at times. So guys, please make sure you tune into this video. I'm going to try and explain the counting probability in a way that when you close this video, you will be able to open your past papers and do those questions on past exam papers, be able to interpret them. Okay, so let us get to it. So when we talk about the counting probability, we sometimes we call it counting principles. So you're looking at the techniques that we use to count different arrangements or different assortments. The techniques that we use to count different arrangements or assortments. Different arrangements. Okay, so I'm gonna jump onto our first example. Say we have you have a coin, you also have a dice, and we know the only two outcomes that you can get out of a coin, it's either a head or a tail. And then this is a six-sided dice, so the outcomes that you can get 1, 2, 3, 4, 5, 6. Yeah, 6. You can get between 1, 2, 3, 4, 5, 6. You can get any of those. So you see you have 2 outcomes for the coin and you have 6 outcomes for the dice. And if I pop in a question and I say what are the different combinations? Remember, you have a coin, you have a dice. Whenever you toss the coin, you're also rolling the dice. Whenever you toss the coin, you're also rolling the dice. So you want to see how many different ways can the coin and the dice be positioned in such a way that the outcomes of the coin are combined with the outcomes of the dice. So we're looking at different arrangements that we can make out of the coin and the dice. So remember, the coin, you can only get a head, you can only get a tail. You can get a head and a 1, you can get a head and a 2, you can get a head and a 3. Remember, the numbers are coming from the dice. You can get a head and a 4, a head and a 5, a head and a 6. Or you can get a tail and a 1, a tail and a 2, a tail and a 3, a tail and a 4, a tail and a 5, and a tail and a 6. These are the different ways. How many if we count them? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 different. Remember guys, different. You'd see I'm not repeating anything there. There's only one H1, there's only one T2. So these are the 12 different combinations. This one is easy to work with because we only have a few outcomes. You have 2 outcomes from the coin, you have 6 outcomes from the head. It's easy to just write that. But now what if I bring a very an event that has many outcomes? Let's say now I work with cards. With cards, we know we have 52 cards, meaning if I say every time when you toss, when you roll your die, you also flip a card on the floor. What are the different combinations? You have 52 cards in your hands. You have 6 outcomes from the dice. So that's gonna be a very that's gonna take us a long time to work it in this manner. So now this is now where we bring in the counting, the fundamental counting principle. Fundamental counting principle. And what does the fundamental counting principle says to us? It says if you have 2 events, let's say events A and events B, and the outcomes of each event, outcomes in each event, in A you have n number of outcomes, in B you have n number of B outcomes. To find the different combinations, I'm just going to put a comma there, to find different arrangements. Okay, I'm out of space there. You would say the total number of outcomes in event A multiplied by the total number of outcomes in event B, and then that's going to give you the different number of, or the different arrangements. If we go back to our example of a coin, our event A was a coin and it has 2 outcomes because that's a tail and a head, and then the other one is a dice. The dice has 6 outcomes because that's 1, 2, 3, 4, 5, 6. To find the different combinations, you're going to say 2 times 6, which is 12. If you check, it still gives us the same total that we got there. We got 12 different combinations. So now it means every time when you have a different events that are taking place, if you have event A, event B, event C, event D, to find the total different combinations that you can make when this event are taking place simultaneously, you will say the total outcomes in event A times the total outcomes in event B times the total outcomes in event C times the total outcomes in event D. So that is the formula that you will use to find the total outcomes. At our first example, for our first example, say you go to a restaurant and you get the menu, and the menu looks as follows. So you have drinks, you have an option on drinks. Say for drinks, I'm not gonna write the full flavors, I'm just gonna write letters. Say for the drinks, you have coffee, you have juice, you have Coke, you have water, you have what else can we have? Let's say you also have Fanta. That's for drinks. And then for the main meal, you can get a burger, you can get pizza, you can get what else can we get? Pasta. Let's say we can get pasta. Some people love pasta, I love pasta. And then on the dessert, okay, you either have ice cream or cake. Okay, and now we want to see how many different combinations can you make out of the drinks, food and dessert. Every time when you choose drinks, food and dessert, how many different combinations can you make? So you're going to say for drinks I have 1, 2, 3, 4, 5, so it's 5 outcomes. For food I have 1, 2, 3 outcomes for food and 2 outcomes from the dessert. Then you have 5 times 3 times 2, which gives us 30. So it means you can make 30 different combinations of drinks, food and dessert at the restaurant. Okay, I hope you are still with me. I hope what I've said now makes sense. Okay, so now I'm going to move on to a new term. We call it permutations. Permutations. So with permutations now, our main concern is on the spaces that you're going to put in your arrangements, meaning you can have less spaces than what you have been given, or you can have the same spaces. Okay, you will see, guys, what I mean when I say spaces. I'm just gonna jump onto the first example. Say you have the word the letters B, F, G, 3 letters, and I say, how many different ways can you make 3-letter words out of these? How many? So it means you have, they say 3 letters, so it means you have 3 spaces where you need to put the 3 letters. And we are saying how many different, meaning you want to have different. You don't want to have the same thing repeating and repeating and repeating. You want to have different combinations. Okay, so we are going to say, because we have 3 letters, when I choose the letter there for the first position, I'm choosing from these 3 letters. So I'm gonna write 3 because I'm going to choose from these three letters. But now when I move on to my second letter, meaning that, let's say I've chosen B. I'm just making an example, guys. It's not always the case. Let's say I've chosen B, then it means how many letters am I left with? To choose on the second space, I'm left with 2 letters. So now I'm choosing the second letter. Say I choose G, it's out, and then how many letters do I have? I have only 1 letter, so that is 1. So that is 3 times 2 times 1, which would give you 6. And now this one, we call it a factorial. A factorial, and the symbol on your calculator is an exclamation mark. For those of you who uses Casios, you have to shift to get that. It's on okay, I'm not gonna state where it is because, guys, we're using different calculators, but most of the time it's written as X and then with that. I think that is it's an exclamation mark, if I'm not mistaken. I'm just not sure. I'm not sure with my English punctuation, but yeah, that one. You just click. We say it's a factorial, meaning when you say 3 times 2 times 1 is the same as saying 3 factorial, which would still give you 6. So the factorial only applies when you start from a number, you go all the way down to number 1. But if it ends somewhere 2, it's no longer factorial, it's something different. Okay, so I hope it's making sense. So let us look at another example on factorial. Let's say now there's 7 of you. 7 of, okay, I'm just gonna do that. 7 of you are sitting in a row on 7 available seats. So it's you and your friends. In total it's 7, you included, so it's 7. Then you are sitting, we have 7 chairs that are sitting in a row, and then you guys are sitting on those chairs. And my question says, how many different ways can you and your friends sit? How many different ways? I mean, if it's 7 positions, 2, 3, 4, 5, 6, 7. Remember what we're looking at there? We're looking for different ways in which you and your friends can sit. Okay, so these are the chairs. I have my chairs there, 2, 4, 6, 7. Remember, if it's 7 of you, you can sit there, or you might find yourself sitting there, or you can sit anywhere. So you want to see now, how many different ways can you and your friends arrange each other differently and sit? So because it's 7 of you, we are going to say on the first chair, because now remember, let's say you guys are on a queue, in a queue. Okay, you have formed a queue, you are the first one. So it means for this first position, it's still the 7 of you because no one has sat yet. So it means I'm going to put a 7 to say I'm going to choose 1 out of the 7 learners, or not learners, but one out of the 7 friends. And then 1 is out. How many am I left with? I'm left with 6. I'm choosing from 6 there. Then it means there's 2 positions have been occupied. 2 people are out. I'm left with 5. I'm gonna write 5 there. I'm gonna write 4 there. I'm gonna write 3 there, 2 and 1. So this says you're going to choose, as you move, you are going 1 friend less. So every time when you choose that friend, we eliminate them, we deal with what we are left with. That can also be written as 7 factorial, and that should be equals to 5040, if I'm not mistaken. Let me just check. Yeah, so it means you and your friends, you can sit differently on those chairs in 5040 ways. Meaning, yay, imagine now if we didn't have the factorial, you would have to now keep on moving. You sit here now, the other one sits there. Now let's move you to the back. So it's gonna take days or even weeks. So this says we can just put 7 factorial because we have 7 seats. We can arrange these friends in 5040 different ways. Okay, so that is your permutations. Still on permutations, you can have no repetitions. You can have repetitions. So now I'm going to start on no repetitions. When we get tested, repetition. When we write tests and exams, when they ask you the question, if they want you to repeat, they will always tell you. But if they don't say anything about repeating, it means no repetition. But if there is repetition, they will always say it. They will say learners may be repeated, or yeah, it will always be said. But if they don't say it, it means there isn't any repetition. Okay, so now if we look at the first example, where we say we are considering or we are assuming that there is no repetition. So let's say now we have an example would be the one with the word BFG. With BFG, we said how many different ways can we form? We said you can choose from 3 there, because the one is out, you're not repeating it, you're left with 2. Because the second one is out, you're not repeating those 2, you're left with 1. So this is an example of no repetition. You can only choose, you can't repeat. If we took out B there, we can't have 2 B's in that word. So no repetitions means you can have the same letter twice or 3 times. Hence, if I chose B out of these 3, then I'm only left with 2 to choose from. So this tells you that there isn't any repetition. Okay. Let us also look at let us make an example with our alphabets. We have 26 alphabets in total, and if we want to remember, we are still under no repetition. And if you want, remember the alphabets that we know, they start with A. It's A, B, C, D, E, all the way to Z. But we can arrange them differently. You can have Z to be the first one or to be the middle. It can be everywhere. But how many different ways can we rearrange these 26 letters? How many different ways? So it means you're going to say, okay, we have 26 spaces. I'm not going to make 26 spaces because that's going to take my entire page. But I'm just going to illustrate it that on the first position, we are going to say, I'm choosing from 26 letters. So you put 26. On the second position, I'm choosing from 25 because repetition is not allowed. The one that I chose there, it can no longer form part of what I have to choose on the second position, which should also applies for that, which also applies for that, which also applies for 23, 22, 21, and so forth, all the way to 1. All the way to times 1. Remember, this is the same as what? 26 factorial. 26 factorial is a very big number. It is 4,03 times 10 to the power of 26. So it's more than 1 million. You can arrange the 26 letters in these different ways. Okay. So, see now, when we give these questions, we are saying you have 3 letters, we are making 3-letter words. You have 26 letters, for example, the 3 letters I'm referring to that. You have 26 letters, meaning we want to fill 26 spaces. But sometimes you're going to work with less spaces. Less spaces. So now, when we do less spaces, we give you a long event, or for example, I'm bringing the example with 26 letters. We have 26 letters in total, but I say how many 5-letter words can we make? How many different 5-letter words can we make? Let me just write that. How many different 5-letter words can we make? You see now I have 26, but I'm only making 5 spaces. I have 26 letters in total. I'm choosing from 26, but I want to fill only 5 spaces. So remember this. Remember when we started, guys, I had said you can either have the spaces to be less or the spaces to be the same. Here the spaces are the same. Here the spaces are the same because we have 7 learners, 7 seats. We have 3 letters, 3 spaces. 26 letters, 26 spaces. But now 26 letters, 5 spaces. It means you're going to say, okay, for the first position I'm choosing from, remember we're still under no repetition. We are not repeating. For the first letter I'm going to choose from 26. For the second letter, because we are not repeating, I'm going to choose from 25. Third letter I'm going to choose from 24. I'm going to choose from 23. I'm going to choose from 22. Then you are done. You have filled your 5 spaces. So it means when you say 26, 26 times 25 times 24 times 23 times 22 times 21, it gives me 165 765 6 7 no not 76 765 600. So these are the different 5-letter words that we can make out of 26 letters. Okay, there's a formula. Remember, you can do it in this manner. You can just put your 5 positions and then you put them, or you can use the formula. There is a formula that I'm gonna show you guys, the one that you use. Remember up here when we were doing the factorial, we said it's 7 factorial. The formula would be n factorial because n is the number of the outcomes that you have. Then also there, because now for the formula we have fewer spaces. The formula would be n factorial over open bracket n minus r factorial. The n is the total outcomes that you have. In our case of 26 letters, this one, the spaces available, we said we want to make 5-letter words, meaning we have 5 spaces, so that's 5. So if I have to use that formula, I'm going to say 26 factorial over 26 minus 5 factorial, and that should give me the same answer. I miscalculated there. So 26 times 25 times 24 times 23 times 22, it's 7896300, which is the same answer that I get there. 3600. 26 factorial over 26 minus 5. Yeah, why is it giving me a different answer? Oh yeah, it's the same, 7893600. So you can either use that or you can use that, whichever you're comfortable with. Just know that this applies when you are not repeating, when you are being given many outcomes but you have less spaces, ne? I'm just gonna also highlight there, this is when you have less spaces. Please guys, take note, please, because I had mentioned earlier that the problem here is knowing which formula to use. So this is part of helping you guys identify the right formula to use and using the right formula, in fact. Okay, so I'm going to move from repetition, no repetition. I'm now going into repetition. Now we are allowed to repeat. I'm going to use the very same examples that I had earlier. I'm going to start with BFG. BFG, same question. We want to make 3-letter words, but repetition is allowed. Okay, it means you can use 1 letter more than once. I'm choosing from 3 letters there, but because I can still use that same letter that side, I'm choosing from 3 letters also. I'm choosing from 3 letters also. So that is going to be 3 to the power of 3, and 3 to the power of 3 must be 27. Let us look at the one for 26 letters. If I want to see how many different 26 letter words, how many different ways I can arrange the 26 letters, different arrangements, I'm going to say, remember, I will say 26 over 26 times 26 times 26 up until I've done 26 of them, which is the same as 26 to the power of 26. And then in a case where you have less spaces, let's say we have 26 letters, but we want to see how many 5-letter words. I'm going to say 1, 2, 3, 4, 5. I have 26 there, times 26 times 26 times 26 times 26, because I'm going to choose from 26, but I can still repeat it, so I'm going to choose from 26 again. This is the same as 26 to the power of 5. Okay, so this is when we do repetition. But there's something that I want to highlight on repetition. I'm going to bring a letter now. Let us look at the letter, the word electricity. Remember, we are still under repetition. Electricity. No, this is not the right spelling. This one, electricity. Yeah, guys, it dribbled me. But this must be the right one. This one must be the right one. And we want to see how many different arrangements can we make out of this. Remember, repetition is allowed. Must I say repetition is allowed? No, let me not say anything about repetition. How many different ways can we arrange? So now the problem now is that, remember, if we looked at our BFG had 3 completely different letters, but this one has 1, 2 E's, it has 1, 2 T's, it has 1, 2 I's, and then it has 1, 2 C's. So many letters repeated. So to work out this one, the formula is always n factorial, meaning you do the factorial of the entire letter, over this part focuses on repetitions. How many times are we repeating something? I'm going to use different letters. We can use R. No, let me not use R, because we used R for position earlier. Let's say we have S factorial times Q factorial times P factorial times etc. This will depend on how many words are repeating themselves there. Meaning, for this one, how many letters out of make up electricity? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this is going to be 11 factorial divided by, we have E. How many E's do we have? We have 2 E's. How many C's do we have? We have 2 C's. How many T's do we have? We have 2 T's. How many I's do we have? We have 2 I's. So it means you're going to say 2 factorial times 2 factorial times 2 factorial times 2 factorial. Because we repeated 1, 2, 3, 4, and we repeated them twice. And then that should give us 11 factorial over 2 factorial times 2 factorial times 2 factorial. 2 factorial times 2 factorial. That gives me 249,4800. These are the different ways that we can arrange the word electricity. So it means what we are getting out of this is, when you have a word that has letters that are repeating, you're going to use that formula. Letters that are repeating, you use that formula. It's not a problem. This would work when they say no repetition, guys. Let me just highlight. When they say no repetition, this is how you would work on that question. I hope you're still with me. I hope what I've said makes sense, because now I'm jumping onto the next part. Now I'm jumping into combinations. This is when, now specifically when we do groupings, when they say we group some things. Okay, groupings. So I want to highlight a few basic things, because this is just around the language that they use when they ask us questions. Whenever we talk about digits, they will talk about digits. They will not tell you which ones. Digits refers to numbers from 0, digits 0 to 9. Every time when you talk about digits, it's 0 to 9. And if you count from 0 to 9, you would see that they make 10 digits. In total digits, we have 10. Whenever they say the first number must be one of the digits, just know you're choosing from 10 digits. Okay, alphabets, we have 26. Whenever they talk about alphabets or letters, 26 of them. Consonants, no, let me know. Yeah, consonants. Remember guys, the consonants are the ones that are not vowels. Let me do the vowels. Remember, the vowels is R, A, E, or U. How many do we have? We have 5. Then what is left out of the 26 alphabets is consonants, is 21. So your consonants are B, C, D, F, G, H, J, K, L, M, N, P, Q, R, S, T, V, W, X, Y, Z. Anything that is not a vowel is a consonant. Whenever they say the five position must be made up of consonants, it means you say, how many consonants do I have? I have 21. So you write 21 there. You will see when we do examples. And then yeah, also odd, and still on the numbers, they can talk about odd and even. Please guys, remember your odd numbers. And here when they say odd digits, they just mean 0 to 9. You not consider anything that is bigger than 9. 10, 11, 12, they don't work. So your odd numbers would be 1, 3, 5, 7, 9. And then your even numbers would be 2, 4, 6, 8, 10. No, sorry, 10 is not supposed to be there. Those are your even numbers. And then let us go to our first example on grouping. So now we're going to look at the word under. Remember, if you have the word under, combinations and groupings, we work under condition. No, let me not use the under. So we have the word under. The first question, we want to know different combinations. So remember, this one, it's just the one that you do combinations or arrangements. It's just the one that you do. How many letters do I have? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5 times 4 times 3 times 2 times 1, which is 5 factorial, and 5 factorial gives us 5 factorial is 120. Okay, 5 factorial is 120. Right, so we have 120 different combinations. But now I'm going to bring in some conditions. I'm saying we are still considering the word under. I want the different the different combinations that we can make. Different combinations to be made when the first letter is N. So when the first letter is N. Okay, so now I'm saying we must start with N. So guys, please, what I'm doing here is how you will approach these questions. You still put in your 5 spaces. You have 5 spaces, and the first letter must be N. You say, okay, that should be N. It means, how many N's do I have? I have only 1, so I'm choosing from 1. So the first letter, I'll always choose from 1 N. So you put a 1 there, and you say, okay, if only the first letter must be N, it means the remaining 4 are the ones that can be arranged in any way. So it means you're left with 4 letters. You will choose from 4, you will choose from 3, you will choose from 2, you will choose from 1. then now it means you have 1 times 4 factorial. Please don't write n times 4 factorial. We want the 1 there. That's what they will mark. So 1 times 4 factorial would give us 24. Okay, so please guys, stay with me. First letter must be n. The second condition I'm saying, first letter must be n, and last letter must be e. Okay, so you still make your 5 spaces because under is made up of 5 letters. First letter we want n, meaning we are going to choose how many n's do we have. I'm just going to write the word under here again so that I don't have to scroll up. I have 1 n, so I'm going to choose from 1. And then the last letter must be e. How many e's do I have? I have 1 e, so I'm going to put an e there. Then I have 1 e, so it means already 2 letters are out because n and e, n must be at the beginning, e must be the last. So how many letters do I have to rearrange in any way in the middle? I'm left with 3. So it means you're going to say 1 times 3 times 2 times 1, which is 1 times 3 factorial times 1, and 3 factorial is 6, then times 1 is 6. 6 different combinations. Okay, so this is how you can play along with the conditions. My third condition, I know this is point number 4, but my third condition is the consonants must be together. Okay, no, let me not say the consonant must be together yet. It must start with a consonant, starts with a consonant and ends with a vowel. So remember guys, when we did the basics, we said consonants, anything else that is not a vowel. Your vowel is A, E, I, O, U. So now you're going to say 1, 2, 3, 4, 5. The first position must be a consonant. How many consonants do I have? I have N, D, R. So I have 3 consonants, meaning I'm going to choose from 3 letters. The last, it must be vowels. How many vowels do I have? I have 1, 2. I'm going to choose from 2 letters. So still guys, even when I wrote 3 and 2, still the first position is going to be filled by 1 letter. The last position is going to be filled by 1 letter. All in all, you are still taking out 2 letters to fill first and last position. How many positions or how many letters do you have left? We have 3. So the middle ones can be arranged in any order. 3 times 2 times 1. So it means all in simple terms is 3 times 3 factorial. Remember, 3 times 2 times 1, that is 3 factorial times 2, and that is 3 times 3 factorial times 2, and that gives me 36. So this is 36 different ways. Okay, I hope you are still following guys. I hope you are still with me. So now we are going into grouping. So now we are going to group, still using the same example, still using the word under. This question of grouping is very common and there's no formula. I'm just going to show you how you will approach it in the most simplest and understandable way. So the first question says, remember guys, we are still looking for different arrangements that you can make if the consonants are grouped together. Consonants grouped together. Okay, so I'm going to write my 5 spaces because we are still using the word under. Which consonants do we have? We have N, D, and R. So we always want either N, D, and R. So I'm just going to write N, D, and R there because we want them to be together, but I'm going to circle them. I will tell you just now why I'm circling them. Then I'm left with E and R. Okay, so whenever you're grouping, you take what you're grouping, you write them together. It's fine, don't worry about which one must comes first. We will attend to that in a second, but okay, in 10 seconds or in 30 seconds. But you take what must be together, you circle it, you treat it as a single item, meaning now you're no longer working with 5 positions as we had 5 positions for under. Since this is a single item, it's a single position. You're going to give it 1 position, then we have a position for E and a position for R, meaning when you do the different combinations, because when they say the consonants must be grouped together, they are not telling us where must we put them. Must we put them there where I've placed them now? Must they be in the middle? Must they be on the last? We don't know. That's why I'm going to say, we will say, because we can arrange them differently. That is your 3 factorial. 3 factorial says, for this part you're going to choose from 3, for that you're choosing from 2, for the last part you're choosing from 1. That's 3 factorial. Remember I said in 30 seconds I'll come back to NDR. They didn't tell us if we group the consonants, must I start with a D, or must I start with R, or must I start with N? The moment we don't, just the very same way that I didn't know if whether I must start with E for these 3 spaces, or whether I must start with the item, or whether I must start with R. Hence I said 3 factorial. Same reason, because I don't know what to start with inside of my circle. It means I can arrange them in 3 different ways. So that also takes me to another 3 factorial. So the 3 factorial, the first one, it's for the 3 spaces, and then the other 3 factorial, it's for what you have in there. I have NDR, it's 3 letters that I can arrange in different ways. How many different ways can we arrange them? 3 factorial. Okay, so now 3 factorial times 3 factorial. Just a moment, let's see. 3 factorial times 3 factorial. 3 factorial times 3 factorial, because we have 3 spaces. That's 36. Yeah, 3 factorial times, yeah, that's gonna be 36. And then another condition on grouping vowels together, guys, you can do this one. You can pause the video and do the very same approach that I did. But yes, I know you have done it. You did pause the video. You did the different arrangements that you can make when you put the vowels together. Now let's check if you are right. So our vowels, we only have E and R. I mean, you have U and E. So I'm putting U. Okay, I'm just gonna use the space at the bottom there. I'm putting U and E there, and then I'm left with N, R, D. So because I'm grouping my vowels, remember, if you group, you give them a circle to say this is a single item. Then I have space for N, for R, and for D. Okay, and I'm saying, because they didn't tell us if the vowels must be in the middle, in the last, or where, it means we can arrange them differently. How many different ways can we arrange these 4 spaces? For the item N, R, and D, that's your 4 factorial. But now also inside of my item, I have U and E. I don't know if I'm supposed to start with E or I'm supposed to start with U. It means I can do it in different ways. It's 2 letters, so that's 2 factorial. So now that's going to give us 4 factorial times 2 factorial. 4 factorial, 1, 2, 3, 4 times 2 factorial. That's giving me 48. Okay, I hope you're still with me, guys. I hope what I'm doing here makes sense. This is how you do the grouping questions. I'm going to give you your own example to do. Consider the word daughter. I'm just going to write the questions, then you will do them for me. The first question, how many different arrangements? I hope you are doing it as I write. Number 2, how many different arrangements? If it starts with H, and ends with R. Three, probability of starting with H and ending with R. Four, how many different ways, how many different arrangements? If the vowels are together. Number 5, I know it's a lot of questions, but what is the probability of vowels not being together? Vowels not being together. Okay, I'm bringing in the probability questions, guys, because I know I didn't highlight on them as I was doing the content, but they do ask us on probability. So guys, I hope you have paused and you are going through the questions. I'm just gonna get straight into the memorandum so that you can be able to mark and see if you understand what we are doing for counting probability. So I hope you have paused, guys. Please do pause and do the question. Remember, this helps you to test if you understand the content that we are going through. And after that you continue the video to see how I do the answers. I'm running out of space, but I can squeeze in the answers. Okay, so welcome back. I know you were paused, now you are back. Remember, our word is daughter. I'm just gonna write it there so that I don't have to scroll up. Daughter. I hope I have spelled this right, because now daughter, yeah, this is spelled right. How many different arrangements? Remember, you just check how many letters do you have. 1 2 3 4 5 6 7 8. It's 8 spaces. Do we have anything that's repeating? No, we don't have. So 1 2 3 4 5 6 7 8. So we say 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, which is the same as what? 8 factorial. What is 8 factorial? 8 factorial is 40,320. Number 2, how many different arrangements if it starts with H and ends with R? I'm still gonna put in my 8 spaces. 4 5 6 7 8. 2 4 6 8. So it's 1 2 3 4 2 4. It must start with what? With H. So I'm just gonna put a H there. How many H's do we have? 1. I'm gonna put a 1 there. It must end with a what? With an R. How many R's? I have 1 R, so I'm gonna put 1. Then if I take out H and R, how many letters am I left with? 8 minus 2. I took out 2 letters, so 8 minus 2 is 6. So you're going to say, I'm gonna choose from 6 there, from 5, from 4, from 3, from 2, from 1. So that is 1 times 6 factorial times 1, which should give us 6 factorial times 1 times 1. That should give us 720. I hope you are still following. I hope you are marking. I hope you got it right. Number 3, the probability of starting with an H and ending with an R. Starting with H and ending with R. I get it. Oh, sorry, I'm not supposed to say I get it because my audience is broad. Remember, we have found the arrangement. We found it to be 720. So the probability of starting with H and end with R, I'm sorry, my abbreviations don't really make sense, would be the arrangement, the one that we got there. arrangement would be starting with H and ending with R over the total, like the total arrangement, the one that we got for number 1, over the different arrangements, which is 720 over 40,320. 720 over 40,320. That is 1 over 56, which is 0.02. Okay, I hope you're still with me. Question 4. Oh, I'm running out of space. I'm gonna squeeze it there. Question 4. How many different arrangements can be made if vowels are together? Now we go and check how many vowels. A, U, and E. So it's 3 vowels. So it's A, U, and E. And then it means we are left with how many spaces? 5, because we have 8 letters in total. If we take out the 3, we are left with 5. I hope, yeah, we are left with D, we are left with G. Guys, it doesn't matter which one you write first, as long as you have the consonants there. H, T, and R. Remember, what do? You go to the ones that you have to group, you circle them, they are a single item. And then you have space for D, for G, for H, for T, for R. The first thing, we have how many spaces? Isn't that supposed to be 5? 2 for 5. Yes, that's 5 plus 1 is 6. So it means you're doing 6 factorial. I'm gonna write that there. 6 factorial times. And remember, inside of our group, we also can arrange them differently. It's how many letters? It's 3. So we can arrange them differently by 3 factorial. So 6 factorial times 3 factorial. That gives us 4,320. Okay, the last one, very common question. Take note. Very, very common question. What is the probability of the vowels not, keyword, not being together? Okay. We did the probability of, okay, so whenever they say not, there's no way that we can go to the with a dot and always separate the vowels. But remember, probability of being together and probability of not being together, they are complementary. So complementary means when you add them, you get a 1. So probability of vowels together, not, I'm just gonna say together. Remember, when we say not, we use that I don't know what we call it, but the cap on top there. So it means it's gonna be 1 minus the probability of vowels together. Meaning it's gonna be 1 minus the probability of vowels together would be the arrangement of vowels together over the total. You always divide with the total that we get. So that would be 4,320 over 40,320. Oh, why are they so similar? 6 factorial times 3 factorial. It's okay. Then 4,320 over 40,320. That's giving me 3 over 28, which is 0.11. Okay, so always, guys, probability of being and not being, they are complementary. It's 1 minus the other. When you add them, you must get a 1, meaning if you want 1, you say probability of vowels together, it's 1 minus the probability of the vowels being together. No, probability of vowels not being together equals to the 1 minus the probability of the vowels being together. I'm also gonna say something. I'm not gonna write, guys, because I don't have space, but still on this part of things being together and things not being together. If the question comes and they don't want the probability now, they just want what are the different arrangements that we can have for the vowels to not be together. That one, I hope, guys, you write this one. Please write it, because I'm not gonna write on my screen, or maybe I can just dash out some of the stuff there. I'm sorry, guys, I'm taking away the answers because I need to write this down. If the question comes, why did I scroll down so much? Okay, I'm just gonna take away that. I hope you have this down. or you can always play back. If they say different arrangements, still on the word daughter, different arrangements where vowels are not together. It's not probability, it's the arrangement. Are not together. So the formula for this one, it's always the arrangement of the vowels being of the total, meaning like for the word daughter, our total was 40,320. So it means, I don't know how to generate the formula, but it's the arrangements of the word itself. Arrangement of the word, meaning in this case it's the word daughter, minus arrangements of vowels being together. Of vowels being together. Meaning you're going to say the arrangements of the word daughter, we had said is 40,320, minus arrangements of the vowels being together. I think we did work that one out there. It's 4,320, and that gives us 40,320 minus 4,320. It gives me 36,000. So always, if they don't want probability, they just want the arrangement of the vowels not being together, you are going to find the arrangement of the vowels being together. You subtract that from the arrangement of the word, the factorial of the word. Yeah, we can also write it as the factorial. Factorial meaning it's you n that. Okay, and then if they say the probabilities, then you do the probabilities, but now you are subtracting from 1. Okay, guys, this is the end of the video. However, I'm gonna make part 2. Our part 2 is going to focus on application. I'm going to bring past exam papers, past exam questions on this, and we'll get to explore. For so long, go through the video. Make sure you do write in the comment section if there's something that you don't understand. I can always help you with that. And do subscribe, guys. Please don't forget to subscribe, because you are going to stay tuned. You're going to get notified when I post videos. And please guys, watch the video until the end. Okay, but if you're listening to this, you probably are towards the end, but I emphasize because I want you guys to master the grouping part. It's always there. You will see when I do application, I will make use of this. You see, I didn't introduce a lot of formulas. The only formulas that I have are the permutation, the formula for repetitions. Those are the only two. We have that one, and then we have the one where you have less spaces, and then we have the one where you have repetition, and you have the permutation. So those are the only 3 formulas. So I hope you enjoyed the video, guys. I hope you enjoyed the video. I hope you understand more than anything. It's not about enjoying, you have to understand the content, because we have to grab those marks under counting probability. And thank you so much for watching. I will see you on part 2 when we do application.